Today we are going to be talking about how to solve basic trig equations. So we're going to begin with just a quick review of inverse trig. So remember, inverse trig is how we undo a trig function. So we undo a sine function by using the inverse sign, or that sign with a little -1 on it. Now the answer to an inverse trig question is an angle. It's finding out the sine of what angle would give us this answer of 0.72. Now remember from our graphs that sine keeps doing that wave motion, up and down and up and down and up and down. So that means there's actually a lot, infinitely many angles that would give us a sine of 0.72. The calculator is programmed to give you what is called the principal solution. And so a couple things to watch for on Khan Academy. It's going to ask for that principal solution. So that's good because that's what the calculator is going to give you. The other thing to watch for is what unit it wants the answer to be in. Does it want your answer in degrees or does it want your answer in radians? And so on your calculator, you're going to need to keep going into that mode, that second button up at the top that says mode, and making sure that on like that third or fourth line down where it says degrees and radians, that you're choosing the correct one for the particular problem. So I'm currently in degrees, so I'll just go ahead and calculate this in degrees. The inverse sine of 0.72 in degrees is about 46.1. Again, also, and I guess another thing to watch for in Khan Academy is your rounding instructions, right? So as always, that's nothing new. Make sure that you're paying attention to your rounding instructions. So 46.1 degrees is the first time that that wave would hit the 0.72 value for that sine. Now, if it asks for it in radians, I'm just going to go in and I'm going to hit that mode button. So I'm going to switch on that like third or fourth line down, depending on your calculator model, and switch it over to radians. And then when I calculate it, I'm going to get 0.8 radians. Okay, so on that assignment, make sure you pay attention to what mode you should be in, degrees or radians, how does it want that answer, and make sure you pay attention to your rounding instructions, okay? And I do believe they all ask for the principal solution, and so then you'll just be ready to give the one that the calculator gives you because it gives us the principal solution, okay? All right, so now solving some basic trig equations. So by basic, I mean all we're gonna have here is a trig function of an angle is equal to some number, okay, a decimal or a fraction, some number. And what we wanna know is what is x, okay? So to undo the sign from that, we are going to do an inverse sign. So I'm going to do the inverse sign. That cancels the regular sign, and it leaves me with just that x that I want, and I'm going to do an inverse sign of 0.5. I'm going to solve this problem in degrees, okay? So on this, again, we're going to want to pay attention to the instructions on the problem. So I'm going to solve this one in degrees. So I'm going to switch over to degree. Inverse sine of 0.5, and my calculator tells me that an answer to the question, the first answer, is 30 degrees. But there's actually many other angles, infinitely many really, that have an answer that would give us 0.5 here. Many different x values that we could plug in and say sine of that x value would give us 0.5. So how do we find those? Okay, well, let's think back to graphing our angles, not graphing our equations. We'll come to that in a minute, but graphing our angles. So like on our quadrant lines. So we just found out that an answer to this question is 30 degrees, and that's what a 30-degree angle would look like. There are other answers that would give us the same opposite over hypotenuse. There are other triangles. There's actually 4 triangles that we could draw that might work out for us. And so we could draw one in each quadrant, and those all have 30-degree angles. So they would all have the same opposite and hypotenuse. However, pluses and minuses might be different. So in the first quadrant, everything's positive. opposite, adjacent, hypotenuse, they're all positive. So no matter whether we are going to do a sine, a cosine, a tangent, we're working with all positive numbers. All of the trig functions are going to be positive in that quadrant. In quadrant number 2, as we go around to the next one, hypotenuse is always positive. That vertical is an up, so it's positive, but on the x-axis, that's a negative. So anytime we use that x-axis, which is the adjacent, we're going to get a negative answer. So sine, we would get a positive answer, because sine is opposite and hypotenuse, and so that's going to work out. But cosine would use adjacent, tangent uses adjacent, so sine is the only one that's actually going to give us a positive answer in that quadrant. So I'm writing out the names of which trig functions give us a positive answer. In the first quadrant, all of them are positive. In the second quadrant, only sine is going to be positive because it uses the opposite and the hypotenuse. Now in the third quadrant, this one's a little bit tricky. If I do a sine, opposite over hypotenuse, that's going to use the negative on the opposite and a positive hypotenuse. So that's going to make a negative. So sine, no good. Cosine, adjacent hypotenuse, that's negative and negative, or negative and positive. So that gives us a negative. Tangent uses opposite and adjacent. Double negative, that makes a positive. So tangent is going to be positive in that third quadrant. Fourth quadrant coming around, we already have that horizontal labeled as positive. The vertical will be negative, hypotenuse always positive. So if I do a sine, opposite is negative over hypotenuse positive, negative positive, that's negative. Cosine, adjacent hypositive, adjacent and hypotenuse, both positive. So cosine, positive. Tangent, opposite, adjacent, we have one negative there, so that'd be negative. So as we work our way around, we have this all sine, tangent, cosine. Now, it's been a memory trick for years, which I actually don't like at all, but it is what it is. This is what many teachers use to help students remember this pattern. They say all, they don't change that one, all students take calculus. Well, it works, ASTC, so it works to maybe help remember those letters, but it's not true. All students don't take calculus. You know, every year I have between 10 and 20 students who take calculus, so it's definitely not all, but there's the memory trick teachers make maybe to try to like promote calculus and try to get more students to take calculus, but it is what it is. All students take calculus can help us remember what's positive in each quadrant. Okay, now this has been like, it seems like a long bunny trail, so let's go back to that problem. We found the inverse sine of 0.5 was 30 degrees. That means 30 degrees is the first answer to this question. What we want to know is, where are the other answers to this question? We are looking for somewhere that has a sine that is equal to positive 0.5, because that's what the original equation said. The original equation said sine is equal to 0.5, just plain 0.5, so positive 0.5. So where else is sine positive? Sine is positive in that first quadrant. Well, sine is also positive in the second quadrant. So if I thought about that second quadrant angle, I start still at my 0 line and work my way around to here. How big is that angle? Well, if the little triangle wedge is 30 and 180 is halfway, then that angle must be 150. So that means 150 is another answer to this question. Well, in the other two quadrants, sine would be positive. So that doesn't work because our original equation said sine of x is equal to 0.5, positive 0.5. So those other two quadrants, that's not going to work because that would give us a negative for our sine answer. But the thing about this is that it's a unit circle, and a circle has no end, which means I could go 30 degrees and get that first answer. But I could also go all the way around and then do another 30 degrees. So like 360 plus 30, 390 would be another answer. But I could do it again too. and add another 360 and add another 360. And I could add as many 360s as I want because that would just land me back at that same 30 degrees in the picture. 360 is a whole circle. So then we're going to say we're going to add on this plus 360n. And that just means start at 30 degrees, go around a whole circle, go around another circle if you want, go around another circle if you want, and you'll keep finding more answers. Okay, so this is the complete final answer to this question, is that our answers are 30 degrees plus add as many circles as you want, and 150 plus add as many circles as you want. Okay, so I want to show you now how you can find these by looking at a graph. Since we just studied graphing, I want to show you how we can find these by looking at a graph as well. And I think you're probably actually going to want to do your homework on the graph. I think it's easier, honestly, than doing this algebra and figuring out the quadrants, but wanted to show you this quadrant approach as well. So I'm going to type in, instead of our original equation, which was sine of x equals 0.5, I'm going to type in y equals the sine of x, and I'm going to type in y equals 0.5. So I'm taking the two parts of the equation, but setting them each equal to y instead of setting them equal to each other. That gives me two lines on my graph. It gives me my sine line that we looked at last week, how to graph those, and then it gives me just a straight horizontal line that's at the height of 0.5 in this problem. Now what I want to do is find the intersections, but I have a problem. I have a couple problems because my daughter's talking really loud. So the first problem that I have is trying to teach in a kitchen. The second problem that I have is that this problem was supposed to be done in degrees. So what I'm going to do is I'm going to go into my settings here and see at the bottom where it says degrees and radians, I need to switch over to degrees, but that's actually really going to mess up my graph quite a bit. It looks totally different now, right? So what I'm going to do is I'm going to change my x-axis to go from negative 360 out to 360. Okay, now it looks kind of like it used to look. I chose 360 because that's a circle. That's how long it takes for a standard trig graph to go through its whole cycle, is around a circle. So now we can look at this, and what we want to do is find where do these intersect or cross each other. So here's my first answer right here. I can click on it and it says 30. So that was the answer that we got, 30. And actually, I'm going to go back into my settings. I'm going to go even more than the 360. I'm going to go out to like 720. I'm going to let us see more of the wave happening, more cycles of the wave. There we go. Okay, so this first answer is 30. That's the first answer that we got, right? Then I had that plus 360, which means another 360 degrees away, we should have another answer. So that would be plus 360, that'd be 390. Oh, there it is, right? So it's going to keep on happening over and over and over, and also backwards. Here's one, minus 330, okay? Keeps happening over and over. But there is actually a second set of answers here, and that's this one right here. Negative 210, add another cycle, so plus 360 makes 150. Plus 360 makes 510. And we get that second set of answers that show up that way. So the first two that I want are the closest one negative and the closest one positive. And then I'm just going to add that 360 to both of those. 360 because that's how long it takes to go through the cycle. So I want to look at another example. So get rid of these. And I'm going to look at, I'll write the equation at the bottom here. We're going to look at the example of cosine of x is equal to negative 0.5. Okay, so we're going to look at cosine of x is equal to negative 0.5 this time. And then you erase all this from our previous problems. And I'm going to show you once again how we would do this with by hand using algebra, and then I'll show you how to do it on the graph. So to solve this, using algebra, I would need to do an inverse. So I'm going to do the inverse cosine of that negative 0.5. That's what x should be equal to. So on my calculator, and I'm actually going to do this problem in radians. So I'm going to do this one in radians. So I'm going to go in mode. I'm going to choose radian. And I'm going to do the inverse cosine of negative 0.5. And I get an answer of x is, I'm going to say 2.1. Okay? All right. This actually has a nice fraction answer to it as well, like in terms of pi, and we'll see that when we go to look at the graph. But let's go ahead and think about where this would be in our circle. So actually, let's go to the graph. We'll go to the graph. Go to the graph. Okay, so I'm going to go and I'm going to type in each part of that equation as a y equals. Y equals cosine of x and y equals negative 0.5. And what I want to know is where do these meet each other? So here's one place where they meet each other. And oops, I'm still in degrees. I'm in degrees. So I'm going to go in and I'm going to switch my mode. I'm going to switch my mode to radians. And now that looks crazy, right? So when we're working in radians, to see one circle is equal to 2 pi, right? So I'm going to go negative 2 pi. And I'm going to go 2 pi. And then I could see one cycle. If I wanted to see more than that, I could maybe go like 4 pi. But when we measure in radians, we're thinking about 2 pi being a whole circle, or 360 in degrees. So here's our graph now in radians. So my first answer right there is 2 pi over 3. So that is equal to, if I do 2 pi over 3, we can see that is the 2.1 that the calculator gave me. The calculator doesn't give as clean of answers as Desmos does, actually. Desmos is a little bit better of a tool that way. So we get 2 pi over 3 is this first answer. And then we'd want to say, well, what are the other answers? Where else do these answers show up? They show up every circle, right? And if we're measuring in radians, then that is plus a 2 pi. So we're going to say 2 pi n. Instead of saying 360 n, we're going to say 2 pi times n, because 2 pi makes a radian circle. 360 makes a degree circle. And, well, here's another one, and it's at negative 2 pi over 3. So we could also have a second answer at negative 2 pi over 3 plus 2 pi n. On Khan Academy, it's going to be multiple choice, and it's going to be choose all of the answers that apply. And what I've noticed that they do is for sine, they like to take the first negative and the first positive answer. Okay, but what I've noticed they like to do for cosine, and there's a reason behind why they do this, the way the functions are defined. For cosine, they take the first 2 positive answers. So we're going to say 4 pi over 3 plus 2 pi n. And so they're going to take this answer and this answer, the first 2 positive ones, and then say those continue through in the waves. Okay, but it's going to be multiple choice, so you're going to be able to choose from the answers there. Another thing that sometimes Khan Academy is going to do is, instead of saying choose all of the answers like this with the 2 pi, it's going to say find all of the answers that are between and give you some boundary values. So let's say on this one, they said find all the answers that are between pi halves and 7 pi halves. Well, then I got to compare thirds and halves, and that's just tricky with common denominators. What you can do on the graph is go into your settings and just change what you're looking at. If I want all the answers between pi halves, I'm going to type in pi. Say I just typed in, and you're like, where's she getting this pi from? If you just type in pi, it changes into a pi. So pi halves to, let's say, 7 pi halves. Oh boy, that's a lot of them. And say find all of the answers that are between there. And so then we've got, so let me click that. 4 pi over, there's 2 pi over 3, 4 pi over 3, 8 pi over 3, 10 pi over 3, 14 pi over 3. This would be a lot. It wouldn't be that big of a window to list out this many points. But it will still be multiple choice, and so then you would just select all of the ones that are here, and if it's not here, then it's not an answer. So on the ones that are between a certain range of values, I would just set my graph to only show me that range of, oh, I typed 14 pi. That's why it's so many. 7 pi, I was like, why is that so many? Over 2. There we go. Now it's not as many. Okay, that makes more sense. Here's my first answer then. 2 pi over 3, 4 pi over 3, 8 pi over 3, and 10 pi over 3 are my 4 answers within that range. Okay, so if we're going for within a range, set your window to show you that range. If we're going for all possible values, then in radians, I would set it to probably like negative 2 pi is good enough, and on up to 2 pi. And then you're going to find your answers. Remember that the way it tends to do it on Khan Academy is for cosine, it's going to take your first 2 positive answers and then add the circle. In radians, that's plus a 2 pi n. Okay? In degrees, it'd be a plus 360. And for my settings in degrees, I would have negative 360 to 360 should be good for you. And then on sine, what it likes to do is pick the first negative and the first positive. Okay, that has to do because that's how the inverse functions are defined. The inverse sine function is defined to go from negative pi halves to pi halves, so negative and positive. The inverse cosine function is defined to go from 0 to pi, so only positive. So that's why Khan Academy is doing it that way. Cosine likes to pick the first 2 positives, sine likes to pick a positive and a negative. Plus 2 pi n in radians, because that's a circle, plus 360 in degrees. Now, some of them, it could be a plus, I'm trying to think if any of your homework problems on this assignment are like this. It could be a plus 180, but I don't, yeah, it could be a plus 180 sometimes too. Let's say we are doing a cosine, let's say it's equal to 1. Oh, and let's say it's equal to 0. Okay, so here's an answer, negative pi halves. Here's an answer, pi halves, 3 pi halves. These are all exactly a pi away from each other. Here's a half of a pi. Here's 1.5 pi. So instead of listing out these as 2 different answers, it actually would say just pi halves plus a pi, plus 1 pi, plus 1 pi, plus 1 pi, plus 1 pi. So that could happen as well, and you can just kind of play with the answers there. Please ask me what questions you have as you're working on it. Feel free to send me screenshots. We can do a Google Meet and walk through some problems together if you're getting stuck. I don't want you to struggle through this alone, so please just make sure to ask me questions, and I am happy to help you. All right, talk to you soon, guys.